Alright, let's look at Chapter 2, a few of the review problems for the test coming up soon. First of all, number 7 says to graph it using the intercept method, which basically, if you recall, to find the x-intercept, you do what? You set y equal to 0 and solve for x. And to find the y-intercept, you set x equal to 0 and then solve for y. So doing this on this problem, if you set if you set y equal to 0, you just have x minus 3 times 0 equals 9. Well, that just goes to 0, so x equals 9. So you'd put your dot over here, somewhere at x equals 9, and then you would do the same thing. You would set y equal to 0, or excuse me, x equal to 0, so you get x minus 3 times y equals 9, so you have negative 3y equals to 9, so y equals that negative 3. And you go down 3 on your graph, put a dot, and then just connect the two points, the two intercepts, and you've got yourself a graph. Alright, number 8 says graph the lines using the intercepts again, so that would be the same process. Doing it a little bit quicker this time. If you set y equal to 0, that whole thing goes to 0, so you have 3x equals 6, x equals 2. Come over to your x-axis, find 2. And likewise, if you set x equal to 0, this whole thing right here goes to 0, and you have 2y equals 6. Divide by 2, and you get y equals 3. Put a dot somewhere close to 3. Connect the 2, and you got yourself your equation. Okay, let's look at number 10, and we'll do a couple of these in this section, and these seem to give people the most trouble for whatever reason, so let's see if we can sort this out a bit. Number 10, they want you to find it in standard form, so just recall that's ax plus by equals c. And remember, we have no fractions, no decimals for a, b, or c, and a has to be positive. So let's just remember that we're simply going to use the slope formula. We have y2 minus y1 over x2 minus x1, and remember, we're going to lock the x and the y as our variables, and then we're going to take the point that they gave us, and this time they only gave us 1, and that's going to be the values that go here for y1 and for x1 down the bottom. So that would simply be 1/3 y minus, and on the bottom the run will be x minus, and we simply plug in our x and y variable. We have our x and our y right here, and we have y minus 5 and x minus the quantity negative 1. Adding the opposite here, change both of those, the subtraction to plus and the negative to positive, and then we're simply going to cross multiply. We're going to multiply the quantity x plus 1 by 1, and we're going to do that on the left side. So we have 1 times x plus 1 equals, cross multiply on the other side. On the right hand side, we're going to get the quantity 3 times y minus 5, and then we simply have a little algebra problem. Distribute both sides. Of course, distributing 1 doesn't really change anything, so the left side just remains x plus 1, and distributing on the right hand side we have 3 times y and 3 times the negative 5, so we have 3y minus 15. And then going back to our standard formula, the x is already on the left, so we simply need to move that quantity 3y over by subtracting 3y, not dividing, but subtracting. And then at the same time, of course, we can move the plus 1 over by subtracting 1. Subtract 1 over here, and we get the following. We have x minus 3y. That 3y and minus 3y is 0. And we have a negative 15 minus 1 equals a negative 16. Okay. I'm not going to do number 11. I am going to talk about it though, because number 11, if you remember that little memory device that we use, Passport, where this is the rule for parallel lines, and the SS there means same slope, and for the bottom one, the perpendicular relationship is that you have opposite signs. So if you have a positive, the perpendicular is going to be negative, or if it's negative, it's going to be positive. And then the R, of course, stands for reciprocal. So whatever your slope is on the original one, you're going to flip that fraction over. So number 11 is certainly a passport problem. So all we're going to do is take the equation that they gave us, and we're going to set it to y equals mx plus b, and m is going to give us our slope. So doing this one pretty quick, we're going to subtract 2x. So we have negative 2x plus 10, and luckily this problem has already had a coefficient of 1 for y, so our slope is equal to 2. So we're going to use that same slope because it's parallel, and we're going to substitute in the point that the parallel line goes through, 2, negative 2. So it'll be just like number 10, except for we're going to put it into slope-intercept form at the end, so we're going to, y equals mx plus b. Alright, let's do one more. Let's do number 13, but let's talk about number 12. Number 12, we're going to set the original equation, 3x minus 4y equals 6. We're going to solve it for y, and then we're going to have a slope. So whatever your slope is, you're going to take the opposite reciprocal. So let me just cut to the chase here. You're going to have y equals positive 3/4 x minus 3/2. And really all you're interested in is this quantity 3/4, because that's the slope of the original line. And setting up, we're going to use that the perpendicular slope is going to be negative 4/3. Okay, and then we'll solve it just like we did in number 10. Alright, let's do the very last one, number 13. It's going to be in slope-intercept form. And this time they didn't give us the slope, but hey, that's pretty easy to calculate, right? We're still going to use our formula that we have written up here, y2 minus y1 divided by x2 minus x1. So let's do this one real quick. We have the differences in the y's, or y2 minus y1 would be negative 5, subtract negative 1, and on the bottom we're going to have 8, subtract 2. Well, the bottom is not very tricky. It's equal to 6. And the top, we're going to add the opposite here. Add the opposite. So we have negative 5 plus 1, which is a negative 4. And so our slope is equal to negative 2/3. So now we know our slope. We're basically just going to take this and we're going to plug it in for slope, for m, and then we're going to use the same technique we did in number 10. So let's try that. We have negative 2/3. We're going to lock in our y, and we're going to lock in our x on the bottom. And then we have a choice. We can pick either one of these two points that they gave us. I choose to use the first one because it's just a little bit smaller. So we have y minus a negative 1, and we have x minus 2 on the bottom. Of course, remember, this is adding the opposite again. So we have y plus 1, and on the bottom we have x minus 2, and we're going to cross multiply. So we have the quantity 3 times that is equal to, remember that we have to take the negative along for the ride on either the numerator or the denominator, so I'm going to do it on the denominator. So we have the quantity negative 2 times x minus 2. Okay. Let's see, we have distributing 3 to both sides. We have 3y plus 3. Whoops. And then distributing a negative 2, we have negative 2x. And then when we distribute the negative 2 to the minus 2, we get a positive 4. So this is in slope-intercept, right? So let's see if we can do this problem. If we have enough space down here. Okay. Let's see. So let's move this minus 3 over, or plus 3 by subtracting 3. And then we were left with 3y equals negative 2x plus 1. And then we simply need to divide everything by 3 so that we've set it to y equals. And we have y equals negative 2/3 x plus 1/3. And it's in slope-intercept form. Alright, hopefully this helps and you're prepared for the test.